So let's begin with the correction. Question 15 as requested. Today we'll complete some maybe difficult questions. I might ask you to try something also in the class. So please pay attention and be a participant, not an observer in the class. Be a participant, not an observer in the class. So question 15 says, given the equation 4y minus 2 all squared, so let's write the date. It's Monday 9. So the equation 4y minus 2 all squared equals to ky minus 1 squared. So k is a constant. It says show that the sum of the roots equals their products. All right, so guys, participants, how did you go about this? Let's start with what you did. Those of you that did it, I want response, please.
May I try the first question? Like,
what do you mean the first question?
I tried 15A.
Yeah, obviously that's what we're going to start with. And that does not answer my question. Okay, Alex, you haven't answered my question if you are answering my question.
Oh, should you put ky minus 1 squared to the left side?
I think there is no square on the left side. Yeah, on the right side, there's no square. Okay. Yeah. So, yes, I'm listening.
You put the ky minus 1 to the left side.
To the other side. Okay, why do we need to do that?
I tried to find the a, b, and c in the quadratic equation.
Okay, so you have this. So what else?
And then I expand
Okay.
the two brackets.
Yeah, then we expand. So this will be 4y squared minus 16y plus 16 minus ky plus k. I have expanded, so what do I do next?
And then you need to get the a, b, and c from the quadratic equation.
Okay, how do I get a, b, and c? This doesn't look like quadratic equation with 3 terms. It looks like equation with 5 terms. So I don't know how to get my a, b, and c.
You put the y in the bracket, like the negative 16y and negative ky into a bracket.
So basically you group them.
Yes.
So 4y squared minus 16y minus ky plus 16 plus k equals 0. And with this, so it's going to be 4y squared minus bracket 16 plus k y plus 16 plus k equals 0. Yeah, that's it. So we get A, B, and C like you said. A is what?
4.
4.
Is
Negative 16 minus k.
there's not that here. Just copy what you see first. And C is 16 plus k. Yeah? So
Yes.
there is no alpha plus beta. Is there anything like that in this question?
No.
No.
Because the question says show that the sum and product of the root. You don't have to call them alpha and beta. But you can say sum of roots, right? Sum of roots is what?
Negative b divided by a.
Good. Sum of roots is that, which is negative 16 plus k divided by 4. And that will be negative cancel negative. So you have just plus 16 plus k divided by 4. Then products of roots.
C over,
What?
is a C over A.
C over A.
C over a.
All right. C over A will be 16 plus k over 4. The question says, show that the sum of the roots equals their products. This is the sum, this is the product. We can see that they are equal. That's it. Yeah, that proves that. Okay, who got that? Who did this?
I didn't do this question.
I didn't do this question too.
Why not?
I thought it wasn't
I
required.
thought it wasn't home. It's not homework, and I need to do other thing. Yeah.
Wasn't there? Oh,
Yeah.
oh, Alex, then why do you bring it up? Is it just?
Well, I think he did practice, so maybe he just wants to know.
So I shouldn't call it correction.
I'm sorry.
That's okay. No, it's okay. It's one of the things we will end up doing today anyways. Okay, that's okay. So we won't call it correction. We just say more practice or further practice. I think I like the word further practice. That's all right. So further practice. So next time, Alex, just because it might be one of the questions I intend asking the class for the day, just clarify from the beginning, oh, this is not part of the homework, but I did this, so can you do this in the class, something like that, so I know. So if I intend asking the class, then it will become an exercise. Otherwise, I'll go ahead and do it as requested, all right? Just to be clear next time.
Understood.
Yeah, so it's good to practice. Thank you. Okay, so B part of the question says, find the value of values of k for which the difference between the roots is that. Who has an idea what to do? I believe everybody has the question right in front of them.
You write alpha minus beta and
That sounds like someone I know.
so you write alpha minus beta and then you change the alpha minus beta sign to something like minus plus open roots, and then I don't know how to describe it.
Okay, calm down. I think hold on. The problem I have with is this. Good observation, very good answering. Okay. Now this is the question. I believe everybody can see the question. None of these things says alpha and beta, so who can suggest what to do before we think about what Ansen is telling us?
name the two roots.
Thank you. Name the two roots by saying let alpha and beta be the roots. Okay? So before you go into this calculation and start calling them alpha and beta answering, you need to name them alpha and beta. It's not automatic in the question. Okay? So I'm going to say let the roots be alpha and beta, or let alpha and beta be the roots. Let alpha and beta be the roots. Okay, then we can do what Elson is talking about, what Anson is talking about. Find the value of values of k if the difference between the two roots is that. So now we don't know which root is bigger than the other, right? So that's why we always have plus or minus. So alpha minus beta, okay? So we don't know which one is bigger. We could say let alpha and beta be the root such that alpha is greater than beta. We could say that. All right, because so we don't have to do it twice. Does that make sense? So such that this happens. So alpha minus beta will be the square root of alpha plus beta squared minus 4 alpha beta, isn't it? Talk to me, please.
Yes, it is.
All right.
Yes, yeah.
Now I assume alpha is greater than beta, so I don't have to do plus or minus roots. Or if I do plus or minus roots and either alpha or beta is greater, we can also do that. So if I say plus or minus here, and this is not part of the question, so I'm going to assume it's not there. Okay. So if I do this, then alpha minus beta, which is this thing, okay, is going to be the 3/4. That is the difference. But then this is 3/4 is a positive difference, which means alpha has to be greater than beta. So this is the reason this condition is very important. I don't know if you are getting my point, everybody, about this condition. Hello?
The condition that alpha is bigger than beta.
Yes. So I'm saying let alpha and beta be the roots. So for example, if the roots are 2 and 7, and I say, oh, let alpha and beta be the roots where alpha is greater than beta. Basically, I'm saying alpha is my 7 and beta is my 2, not the other way around. So I'm being specific now. So being specific allows you to remove this plus or minus so that it is safe for me to write alpha minus beta is this. Now, if I do this, I can be assured that my alpha minus beta is 5. But if I do not put alpha greater than beta and I just assign alpha here, beta here, you will notice that my alpha minus beta will be minus 5. So I'm not sure whether to put plus or minus here because I don't know. Okay, but in any case, I don't need it. Do you know why I don't need it? Because if I decide to square both sides, all right, if I square both sides from here, whether plus or minus of this, and I square this side, does it really matter now?
No.
No.
Exactly. So if I square both sides, whether it is plus or minus 3/4, this does not, nothing changes. Okay, so instead of giving myself unnecessary stress, I could just restrict it from here by saying, oh, let alpha and beta be the roots with alpha being the bigger one. So whenever I write alpha minus beta, I write a bigger one. I'm using it only for this question. It doesn't mean when you're asked to evaluate this, then you say, oh, alpha is greater than beta. No. Am I making sense?
Yes.
Yes.
So that is the reason I'm doing. And if you do not restrict it, it's still okay. So what you will do is to put this plus or minus. I'm going to change the color of the plus or minus because it's not necessary because I have restricted. Okay. So this is not necessary because of this. Does that make sense? So if you do not put this, you can put this restriction. If you put this restriction, you don't have to put plus or minus. Either way, you can still solve your problem. Can I get more response from more people? So I'm sure that everybody get the message here.
I understand.
All right.
I understand too.
Okay, good. So this still remains that. Remember, they said the difference between the roots is 3/3/4. So the difference is this, and that's 3/3/4. So now we square both sides. Squaring both sides, it becomes, whether I have my plus or minus, remember my plus or minus depends on how I declared everything from the beginning, yeah? So this is going to be 4 times 3 is 12, 15. And this is alpha plus beta, then 4 alpha Newton. So this is automatically, all right, so you can see your sum and product are the same, right? From A, this is 225 divided by 16. Alpha plus beta is the sum, 16 plus k over 4 all squared. Alpha beta, 16 plus k over 4. See that? From here.
Yeah.
Okay, so now k is the only variable here. Okay, so what we can do is to clear the fraction, open the bracket first. So we open the bracket by saying 225 over 16. So if I expand this, I'm wondering if there's a better way instead of expanding it. Yeah, I could look at a better way, but I think for your level, because I could think of this as a variable. So I could think of this as b. No, instead of b, I could think of this as m and m. So I solve the equation for m. Then I put it back. Do you understand instead of expanding the bracket? Am I making sense, everybody?
Yes.
Yes.
Yeah.
I think that's a better way. Do you agree, or do you want me to expand and do the long one? Should we change the variable?
Can we
Do I just
try
expand?
both?
Sure. Just use a variable.
Okay, let's try both like Justin said. So I'll start by saying let's 16 plus k be m. Oh, no, that's not m. If 16 plus k is m, then this problem becomes 225 over 16 equals m over 4 all squared. This is what I'm saying. Minus 4 m over 4. Okay, so this is going to be 225 over 16 equals m squared over 16 minus m. Then we can multiply by 16. Okay, so if we multiply by 16, sorry, we're going to be getting what? 225 equals m squared minus 16m. So if you rearrange by taking this to the other side, m squared minus 16m minus 225. So the equation is m squared minus 16m minus 225 is equal to 0. So what are the factors of 225 that gives 16? Calculator and investigate. We could check if we can get the factors first by doing b squared minus 4ac. So b squared minus 4ac gives 1156. Does it have square root? Yes. So since b squared minus 4ac, which is 1156, has square root, that's a square number, then we can get the factors. Do you get what I just did? I tried to investigate first if I can actually find factors, which means can I factorize? You can factorize if you can do b squared minus 4ac and you get a square number. Why is my m so horrible? Okay, it's better now. So what are the factors?
9 and 25.
9 and 24. Okay, let's see. 9 times 24 is 216, and saying, where do you get that from? Oh, 9 and 25. Are you saying 9 and 25? Or 9 and
Yes.
24? All right, okay, 9 and 25. So to get the negative 25 plus 9, yes, that works. So 9 and 25 are the factors. So it's going to be m minus 9, and actually m plus 9, then m minus 25 equals 0. The product of plus 9 and minus 25 is negative. The sum of these two is negative. That's it. So from here, m plus 9 equals 0, or m minus 25 equals 0. So m equals negative 9, or m equals plus 25. But m is not a variable, so you come back here. Okay, so you come back here. Do you understand? So we come back here. So I will say recall 16 plus k equals m. So in each case, we're going to interpret this, okay? In the first case, 16 plus k equals negative 9. In the second case, 16 plus k equals plus 25. So from the first case, you get minus 9 minus 25, which means k equals minus, no. Where do I get that from? Minus 9 minus 16. So which means k equals negative 25. And in the second situation, we get k equals 25 minus 16, which means k equals 9. So these are the two values of k when alpha minus beta is that. So that's one method. We did this substitution to avoid unnecessary workload. I'll give you examples of equation where we did this. So maybe, for example, somebody says you're trying to solve equation. I'll show you one thing now. I'll do the second method. So if I'm trying to solve x squared minus 16x plus maybe 1, okay, and let's see. Okay, so let's say this. Then I have x squared minus 16x plus 7. Okay, something like this, and maybe plus 5 is equal to 0. So rather than do this directly, I could say x squared minus 16x plus 1 is m. So this would be m squared, and this would be m plus 6 squared. Now this would be m plus 6, then plus 5. Can you see that? Because if this is m, then this is actually plus 1 plus 6. Talk to me, guys.
Yes, yeah.
Yes.
This is the kind of situation where we use this. So by the time you solve for your m, you take it back. So if, for example, m is equal to maybe 1 or 2, then you come back and say x squared minus 16x plus 1 is equal to 1. In the first one, you solve the equation. Second one, you solve the equation. So we use some of these things in grade 11, especially, and 12. Okay, when learning some of this difficult maths, instead of solving that other stuff, there's this particular textbook. If I'm able to find it, either now or when I go home, because it's a Nigerian textbook, I think. No, we use it a lot in Nigeria, but it's actually not a Nigerian textbook. If I'm able to find it, I'll get, if I can have somebody send me a picture of the pages, because some of those books, I wonder if they are online actually. It's old textbook. If I can find them, then I'll show you some of the sample questions we use the system for. So that's where the idea came from, all right? So now, the second approach will be to do the full expansion Okay, so let's do that. So if you do not do this, or, because that's not to say when you are solving the question, you put or. I don't want to see that. So with or will be from here. Okay, this is one method. So from here. So or from 25 to 25 actually. Here, let's check. Okay, that's a minus, not a plus. You always want to check. Okay, that's what we have. So from here, we can do full expansion. 225 over 16. I don't want to mess up stuff, so I'm going to just expand the denominator and leave this for now until I'm able to clear the fraction. So then this will contain the bracket. Can you see? Unlike here, it was just a single term. Here, so just a single term, so it was easy. But here is a binomial, so you have to be very careful. So we can multiply by 16. Multiply by 16, you still get your 225. You still get this 16 minus plus k all squared. And now you have 16 plus k. So this is going to be 225. 16 plus k squared will be 256. 32k plus k squared. Can you confirm if you understand that, please?
Yeah.
Yes. Yeah, I understand.
That is 16 plus k, 16 plus k. So you have to do the expansion. And this is minus 256 minus 16k. So with this, you can see that this and this cancels. Okay, so I'm just going to put the underline so I don't mess things up. So equation reduced to 225 equals 32 and 16 gives 16. So get k squared plus 16k. Isn't that the same equation here? Okay, it looks like it. Not exactly. Can you see? It looks like this.
Yes.
All right, but this is plus. Why this is a plus? This is minus. Okay, let's see. You'll see now. This is just because we need to get our k directly. So if I put 0 here, I have k squared. I did that so I don't have to move this to here and multiply by negative. All right. So that's why I decided to move the only term that is isolated. Okay, then now I can flip everything. K squared plus 16k minus 225. So we still need the same set of factors. We just need to change, like Anson said, the factors are 16 and 9 and 25. So we are still using the same factors because we are still talking about the product as 225, negative 225. But the sum this time is not minus 16, rather the sum is plus 16. So it's going to be k, instead of minus 9 to be plus 9, then k minus 25 instead of plus 25. This still gives plus 16, both of them, and the product gives that as well. So from here, k equals to k minus, I hate shortcuts, I hate. So place plus 9 equals 0, k minus 25 equals 0. Okay,
Daniel?
yes.
Isn't it the other way around where 25 is positive and 9 is negative for
That's the, sorry about that, thank you. Thank you. All right, so it should have been k minus 9, k plus 25. So k minus 9, k plus 25. So k is 9 and k is negative 25. Now, if you look at this, what we got for m are negative and negation of what we got for k. Okay, so that's why the equation are looking alike, but just a change in sign, because what we got here, the sign will just be changed to get the exact value for k, and that's what has happened here. Any questions?
No, not personal.
No.
So that solves that problem. Okay, so now I'm looking at the worksheet now. I'm going to share mine with you. So the homework you did were 2, 3, 11, blah, 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 and 14. I believe there are no questions on that. Okay, so I will need you to practice. I give you about 5 minutes to practice. Of course, I don't have to turn in the work. Let's see which one now. 16. Or is 16 part of the work, homework? No, okay. Practice 16. Okay, understood everyone? Got it? Practice 16.
Yes.
Find the two possible values of R for which the quadratic equation has roots this. So everybody open your worksheet and practice 16. I'll go back to the board and leave my solution on the board. Five minutes, okay? Let's try to be, no submission, you don't have to send it to WeChat. So, but practice, when you're done, then I'll tell you all to send what you have done to WeChat. But don't send anything to WeChat yet, okay? So I'm going to explain this again. Identify your ABC. That's what you have. The question is simple. Question says, find the two possible values of R for which the quadratic equation given has the roots given. Identify your ABC. This is sum of roots. This is the product of roots from this equation. Okay. Now, once you do that, the same sum of roots is the sum of this, because these are the roots we are talking about. The same product of roots is the product of this, because these are the roots we are talking about. So from sum means alpha plus 1, and that is negative R. So basically 2 alpha plus 1 is negative R. Well, there's nothing I can do with this, so I leave it at that. I go to the product. The product of roots simply means alpha multiplying alpha plus 1, and that is 6. Oh, okay, this makes sense because I only have one variable. So I have alpha squared plus alpha, the minus 6 is equal to 0, which I can write as alpha minus 2, alpha plus 3 equals to 0. So alpha minus 2 is 0, either this or that equals to 0. So basically alpha is equal to 2 or alpha equals negative 3. So now that we have values for alpha, then we can go back to sum. From alpha to alpha actually. Maybe I code it. So this. So from that, because there are two values of alpha now, so it means 2 times 2 plus 1 is equal to negative R, or I'm trying to write it side by side. So I'm going to reduce my fonts, if I may call it font size. Okay, so from here, it means 2 times 2 plus 1 equals negative R, or 2 times negative 2 plus 1 equals negative r. So what have we done? This is the case when alpha is equal to 2. This is the case when alpha equals negative 3. That should have been negative 3 actually. So this is negative 3. So from here, I have 4 plus 1 is negative r. So r is negative 5. Here I have negative 6 plus 1 is negative r, which means r is plus 5. Does that make sense? Who got it?
Yeah.
All right.
Yeah, that makes sense.
Okay. So that's that. So I'm going to ask you to try something else again. So let's see. Let's see. Go to the first worksheet, Symmetric Properties Application 1. I believe we all have that too. I'm going to show that. Okay. This worksheet that was given, dated February 26. Okay, so come with me to question. Did we do 9 as homework then? Okay, we only did 7, then 10. Okay, so 9 is available. Okay, so this should be easy, so we're not going to waste our time on that. All right, let's start with that. Question 9, everybody. Attempt question 9. Then we're going to attempt 12. We're going to attempt 11, then we do 12, 13, 14, and maybe 15. Okay, so let's start with 9. Attempt question 9. When you're done with 9, go to 11. Okay, 9, 11, and so on. Okay, 9, 11, and so on. So I'm going to give you about 10, 20 minutes to do attempt on those problems. Okay, then let's say, yeah, 10, 20 minutes so we can do the correction. This is 12:17. So we have about, how many minutes now? 43 minutes. So let's take 20 minutes and maybe the last 23 minutes can be for correction. So I'll just pick randomly, maybe 2 of them to solve, then that could give you an idea what to do. Or maybe I can reduce the question to do so we can focus properly. So after question 9, you could do 11 like I said, then instead of 12 to 15, you could do question 12, no, question 13, and then question 15. So I write that on the board. 9, 11, 13, and 15. 9, 11, 13, and 15. So I write that on the board now. Okay. I'm sure you all have the questions now. 9, 11, 13, and 15.
Given that we are the root of quadrant.
What?
Sorry, I was reading the question.
What do you mean?
I was reading the question, sorry.
Okay. Oh, okay. So you're not talking to us. 20 minutes, please. So by 11:40, we'll come back to solve together.
What? No, you expand it and then you substitute the
substitute,
alpha plus beta.
Did you forget what substitute?
Oh, thank you very much.
You're welcome, Hoyo.
Know how to do question 11.
I'm also stuck.
Hi, Justin.
Hello.
So can someone who's smart explain, please?
Question what?
11.
Question 11. Let's see what we have. Question 11 says alpha and beta are the roots of that equation. So you should do alpha plus beta and alpha beta, yeah? So find in terms of alpha and beta the roots of this equation. The root of this equation, you can write okay, what is the sum of this root? Yeah, I think we can do that. What is the sum of the root of the new equation?
Negative b over c.
Negative b over c. All right. So if negative b over c is the sum of these roots, then how can you write it in terms of alpha and beta? Can you think along that line? Or you could just go to the next one if you can try it. So my point is this. This is what I mean. Let me show you something. Not like a solution. So you have your alpha beta, the root of ax squared plus bx plus c equals 0. Yeah. So from here, get your alpha plus beta, get your alpha beta, minus b over a and c over a. Then you want to get the root of this other equation in terms of alpha and beta. The other equation is CBA, okay? So cx squared plus bx plus a equals to 0. So from here, you think of the sum because they are not alpha beta, yeah? The sum, or you can call it alpha 1, beta 1, it doesn't matter, but sum is better. The sum here is negative b over c. The product here is what?
A over C.
So is there a way you could write this? So I can see personally that this is actually what? A over C is actually 1 over alpha beta. Can you see that?
Yes.
Yes.
So now we need to try to express this and maybe something can come out of it. So this is an idea that I'm thinking about. So think along this line and see what you can find. Otherwise, move to the next one. Has anyone been able to try it? You can share your idea with the class. Otherwise, when we do the correction, I'll think of what to do. I'll tell you the correction. Okay? So if you get stuck in that, go to another one. But this is something I will do first if I want to do it. So others may share ideas. Do we have people who have made successful attempts? Please share whatever you have done with the rest of the group. Thank you. For others, please continue with the other question if you don't have a way around this. The other two questions might be easier to do. Okay? See you in about 10 minutes.
substitute them with a known number and see what the answer is.
But we don't have a known number.
Yeah, just make up one.
Create
See
one.
the relation.
Did
Just
you see
create a
what I just
number.
wrote? Did you see this? Does everybody get this?
No, I don't know what happened to 1 times alpha and 1 over alpha
Did
times
you
1
get
over min.
this? Did you get
Yeah,
this?
I know how to get this.
Okay, so 1 over alpha beta, isn't that 1 over alpha times 1 over beta?
Yeah.
And
but
if we
what-
say this is product, so it means this is multiplication of two things. Product means times. Product of roots, product of 1 over alpha and 1 over beta. Could 1 over alpha and 1 over beta be the roots we are looking for?
Oh.
So that's why I said check the sum. So if your sum is this, then these are the roots you are looking for. It looks like a previous question where the first equation doesn't give us a solution. You have to look at this product to give you solution before you come back to the first equation. So the same thing here, in here. So from the product, you could see that easily, like I said earlier, all right? 1 over alpha beta, you have 1 over alpha and 1 over beta. Are these the roots? Come to the sum and check. If you can add them together and you are able to get what you got for this, and what you are able to get minus b over c, then yeah, maybe they are the product. Try that. Okay? Questions? Does this make sense a little bit?
Wait, I'm sorry, I'm a little behind. I'm still confused how to get the 1 over alpha beta.
Come on, if I write 1 over 4 times 1 over 3, isn't that 1 over 4 times 3?
Yeah.
So 1 over 4 times 3, and I've written it as 1 over 4 times 1 over 3. Is there a problem with that?
No problem.
That's what I've done here. That's what I've done here. So we have 1 over alpha beta, and I broke it down into this. Does this make sense?
No, as in how AC goes to 1 over alpha
Does
beta.
this
Because
make
alpha
sense?
beta is C over A.
Okay, cool.
This is
Thanks.
from here, yeah, like that. Okay. I assume those that are quiet either understand what we are doing, or they have done it, or I don't, or are they just in the habit of being quiet? And when I ask, maybe in the next 5 years, you tell me, oh, I never understood what you said. I just decided to be quiet. Is that what I'm getting? Because I'm going to test most of these things when the school resumes. And I'm positive we are either resuming end of this month or next month, early next month. I'm positive. Because with the way things are going, it seems coronavirus is not an issue here again in Macau. So I'm hoping the school opens in the next few weeks. And of course, I'll start by giving you a test of what I've taught. So if you like, do your layback thing, but I won't let you delay my class. I'm not going to give you the chance to delay my class by saying, oh, I never understood, so I need you to teach everything all over again. That's not going to happen. So I don't know why you like to just hide behind your cameras and mic and decide not to be part of the conversation. But you will not hold my class ransom by asking me to come back at everything that I've said. That's not going to work. Thank you. Have you been able to try question 13 and 15? Anyone? $13 or 15?
I'm doing question 13.
Who is doing 13?
Kelly.
13, okay. So how about we take 5 minutes?
Okay.
All right. 5 minutes only, please, because of time. It's 12:40, so I want to spend maybe the last 15 minutes. I'm just going to go to question 13 and 15, but I want to see your attempt first. Can I have everyone's attention? Has anyone tried 13?
Me.
Me. All right. So anyone else aside Kelly?
I tried, but I don't think I got anywhere near.
Okay, nice one. That's all we need, attempts. Who else?
I'm trying 13, but it's just the beginning.
I
Okay.
tried.
Okay, good work, everybody. All I want is attempts, all right?
I still don't understand 11.
Okay, so we're gonna look at that now, 11 and 13. So let's quickly, 11. I'm trying 13. I think it's better you speak to whoever is typing, because I have two applications open. The video application, the video screen is open. That's the way I see it. I have to open my board, and the last thing I want is go back and forth and open the chat. So which is why I told you to please talk to the mic. Okay, so if you send me any message on the chat, it's as good as not sending me any message at all. I still see you as being laid back and not talking. Okay, if your mic isn't working, do what Giselle has been doing from day one. Connect your phone and speak through the phone. Okay, that's what you can do. You can join twice and speak through the phone. Thank you. All right. Who says I still don't understand 11? I've explained that here because we don't have time. Quickly.
Can you explain 11 really quickly?
11.
I got assist from friend. I understand now. Thank you.
So who still needs help with 11, please? Anyone?
Me, can you go over it?
All right. So remember we've gotten to this point. Yeah. Do you remember up to the point that I have on the board now? I'm talking to Giselle.
Yes.
Can you respond next time? Thank you. So this is simply 1 over alpha times 1 over beta. So can we say the roots of this new equation is 1 over alpha and 1 over beta? Remember, the question is saying, find the roots of the equation given by this in terms of alpha and beta. So this could be the root because the product says these are the roots. But again, the 1 over alpha beta could have been maybe beta squared, let's see, beta squared over alpha times, let me see, alpha squared over beta. No, not this one. I'm trying to see how we can get 1 over alpha beta as well. So, okay, it could have been something like alpha squared beta squared divided by alpha beta. So, and this could have been as a result of beta squared over alpha, yes. And no, this question should be at the bottom. Apologies, sorry. This is the simplest form, okay? If it wasn't this, it could have been maybe something like alpha beta divided by alpha beta squared that was eventually reduced to this. Understood that, Giselle? It could have been that. And what can we multiply to give us this? Maybe the roots were alpha over beta squared and beta over alpha squared in the first instance. And when these are multiplied, you are going to get this. Okay, but I decided to use this and we can check. If this doesn't work, then maybe we could try the other one. So what do I mean by if this doesn't work? So let's see how we can check this. The roots could be this. Please tell me you understand what I mean by the roots could be this.
Yeah, I understand.
Okay, good.
Yeah.
And you understand what I mean by this could be another possibility because the product is this.
Yeah, I understand.
Okay, so this looks complicated, so I'm trying to use a simple case. So I need to check for the sum. if my sum will give me this, there could be other ways to do this, but this is something you can quickly do to figure this out, all right? So if you check for the sum, just add this root that you are assuming to be the case. And this is going to be beta plus alpha over alpha beta, which is simply alpha plus beta over alpha beta. Alpha plus beta is here, alpha beta is here, minus b over a divided by c over a, which is minus b over a times a over c, which is actually minus b over c. And that is this. So definitely, these are the roots indeed. So the root of the equation, this in terms of alpha and beta, are 1 over alpha and 1 over beta. That's the point I'm trying to make. Can I get a response? I have 8 minutes to the end of my class. The last thing I want is absolute silence.
I understand.
Thank you.
I understand.
I'm going to do number 13. If one of the roots is twice the other, show that that happens. So the equation is ax squared plus bx plus c. We have the equation, and for the equation, straight away we can find alpha plus beta. No, of course, nobody calls it alpha plus beta. The instruction says if one of the roots is what? If one of the roots is twice the product, all right, it's twice the other, sorry, not the product. So again, let alpha and beta be the roots. Okay, then according to the question, one of the roots is twice the other. That's the meaning of one of the roots is twice the other. That's what we have. But from the equation, okay, maybe that should have been my first, actually. Let alpha and beta be the roots, then that happens. So from the equation itself, what do you see? Alpha plus beta is, because you already said alpha and beta are the roots, negative b over a. Alpha beta is c over a. But you know this, right? So I can call this 1, and I can call this 2. Okay. I can put here and here. So I'm going to try to eliminate the variables and make it just one variable. Okay. So put alpha equals to beta into 1. Can you confirm if you understand what I'm doing? So I get 2 beta plus beta equals minus b over a. Does everybody get what I'm doing? Because nobody is responding.
Yes.
Yes. Yeah.
So 3 beta equals minus b over a. So beta equals minus b over 3a. So I'm going to call that 3. Similarly, I could put the same alpha equals to beta into equation 2. I'm dealing with these 2 equations. So instead of alpha beta is going to be 2 beta beta equals c over a. Understood that? So 2 beta squared equals c over a. Right? And that means that beta squared equals c over 2a. Okay, so this is beta. This is 4, all right? So I'm going to use 4 and 3 now. So I'm going to say put 4 into 3 or equate both of them. So 2 ways I could do this. 2 ways I could do this. I could say put, no line, it's not so confusing. So I could say put 3 into 4. So from 4, you have beta squared to be c over 2a. From 3, you have beta is equal to that, so you can put that on the left. beta is minus b over 3a squared is equal to c over 2a. So this is going to be b squared over 9a squared equals c over 2a. You cross multiply, you get 2ab squared equals what? 9a squared c, right? And a is definitely not 0, right? Can a be 0?
Nope.
Why? Why? Why can't a be 0? Quickly, please.
Because if a is
Then it
0, then
wouldn't
it
be a
won't be a
quadratic
quadratic equation.
Exactly. So since a is not 0, we can divide by a. Because if a is possibly 0, you cannot divide by a. In this case, I can't divide by c because my c could be 0. And nothing in this question says c is not 0. So I can't not assume that c is not 0. But I know for a fact that a cannot be 0. So I can divide that. All right. If I divide both sides by a, I get 2b squared equals 9ac. Isn't that what we asked to show in number 13? Can you see that?
Yeah. Yes.
If you do not want to go like that, you could say from, after you get 4, you can say from 3, your 3 says beta equals minus b over 3a. Then beta squared will be b squared over 9a squared. Then you can say equate to 4. Or equate with 4. Is it to 4 or with 4? I don't know. Why am I equating with 4? Because 4 has beta square. Now that I could manipulate B3 to also have beta square, then I can equate. If I equate with 4, then I could say b squared over 9a squared equals c over 2a. And that gives me 2ab squared equals 9a squared c, which I could continue this way. Does that make sense?
Yeah.
Yes.
All right. So the last but not the least, that is question 15. If one of the roots of that equation, so again, one of the roots, so let alpha and beta be the roots. If nobody says that, you have to say it. 15. Let alpha and beta be the roots. Then what can you say immediately? Then what?
Then alpha equals to beta cube.
Think again. It says alpha equals beta cube. Think again. Got a question?
1 over beta cube.
Yeah, 1 over beta cube. Then alpha equals 1 over beta cube. Why do you say 1 over beta cube, Justin?
It says cube of the reciprocal.
Cube of the reciprocal. Reciprocal is when you flip it. Cube of the reciprocal means after you flip it, you cube it. So that's 1 over beta cube. Does that make sense?
Yes.
All right, good. So we have that. With this, let's now go to the equation itself. The equation itself is what? X squared plus px plus q. So from x squared plus px plus q equals 0. Alpha plus beta is negative b over a, right? Let me see. Yeah, negative b over a. I hope that's what I did here also. Yeah. In this case, negative p over 1, which is negative p. Alpha beta is c over a, which is what? Q over 1, which is equal to q. So now alpha is 1 over beta q. Let's do the same that we did here. Remember, let's keep our eye on the goal. The goal is to establish what? The goal is to establish q to power 4. Write that somewhere, tiny, so we can always say, okay, this is where we're going. Q to power 4 plus 2q minus p squared plus 1 equals 0. So this is the goal. Okay, this is the goal. I hope you don't have class like now. Can I still have like 5 minutes to wrap this up?
I don't
Yeah.
think we have any class for the rest of the day.
Yeah, we don't have any class for the rest of the day.
Okay, so we quickly wrap this up. Let's see. Now, let's see how we can achieve this. So let's start by going substituting as usual. So I'm going to call this equation 1 again, and this equation 2 again. So it's easier to maybe do this first, but it doesn't matter. Either way is fine. So let's say from here. Okay, so alpha from 1, alpha plus beta is equal to negative p. So your alpha is now 1 over beta cube. So 1 over beta cube plus beta equals negative p. Well, that's not giving us something that makes sense. Okay, how about we do 2 first? Let's do 2 first. From 2, alpha beta is equal to q. So alpha is now 1 over beta cube. Then multiplying beta is equal to q. What does that mean? It means 1 over beta squared is equal to q, right? So 1 over beta squared is equal to q. What does that give us? Now, if I do beta plus 1 over beta cube, which is minus that, let's see. I'm trying to get q to power 4, yeah? Power 4 of this gives us fourth power. Okay, so q to power 8. Okay, let's go to equation 1 again. From equation 1, we have alpha plus beta from 1. Maybe I write from 1. Sorry. So from 1, alpha plus beta equals negative p. Okay. Then we can see that's some kind of a p square here. Anyway, so if we substitute, if I square both sides, I get my p square. And this is going to be alpha squared plus beta squared plus 2 alpha beta. Okay, let's square both sides. We square both sides, alpha plus beta squared equals p squared. So this is alpha squared plus 2 alpha beta plus beta squared. Yeah, I'm just trying different things. So let's put this together. Alpha squared plus beta squared plus 2 alpha beta is equal to p squared. Is that understood so far?
Yes.
So
Yep.
now alpha squared plus beta squared is alpha plus beta all squared minus 2 alpha beta. Then I have, it's like going back again. Okay, that doesn't make sense. Okay, that doesn't make sense. It's like going back again. All right, let's see. If you have suggestions, please you may speak freely. So if I substitute from this point, what do we achieve? Alpha plus beta is negative p squared. If I substitute this in there, it doesn't really make any difference. All right, let's see. I'm trying to achieve my p squared because the solution has p squared. That's why I went this route. Let's just substitute first. So if alpha is 1 over beta cube, so I have 1 over beta cube plus beta equals negative p. And this is going to be beta raised to power 4, which really doesn't make any sense. Stop. What's going on? If I combine this, all I could get is 1 plus beta to power 4 divided by beta cube equals negative p. I'm trying to see how I could substitute this in here. Trying to see how I could substitute that. Maybe I could one way or the other. No. Okay, so alpha again 1 over beta cube, then plus beta equals minus p. Now this is 1 over beta squared 1 over beta, then plus beta equals minus p. Now this is q. So I'm trying to see if I can do q over beta plus beta equals minus p, something like that. Can you see what I did? So this is going to be q plus beta squared equals minus p beta, which doesn't really make any sense. Am I missing something? Is somebody looking at something I'm not looking at? Please let me know. Let's see. There's a q to power 4. What if we put all this to power 4? If we put this to power 4 on both sides, alpha 4 beta 4 equals k to power 4. Okay. Let's 2q. Wait. What's going on? Oh, okay. Then what is 2q? Am I doing something wrong from the beginning? 2q will be twice alpha beta. Are you seeing what I'm saying? P squared will be the square of this. Okay, let's try that. That looks a bit weird. So rather than trying to prove from the question, let's see if I can attempt it from left-hand side and see if I can achieve the right-hand side. Am I making sense, guys?
Yes, Mr. Daniel.
Yes.
Yeah, I guess.
I've tried with the way we did the previous one. It wasn't working as I expected. So why don't we see the left-hand side? Since we are trying to prove something, right? We're trying to show that q squared plus 2q blah, 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 plus 1 is equal to 0. So why not simplify this and make sure we get 1? Okay, so to show, okay, q squared, q to power 4, sorry. Okay. I don't know if this is the best way to do it, but that looks like something we can do now, equals 0. To show this, I can start with left-hand side. My left-hand side is q squared, q to power 4. Why do I keep saying q squared? Minus p squared plus 1. I'm not going to say it's equal to 0, so I'm going to try to simplify this. So since this is q, so that is going to be alpha beta to power 4. 2q to alpha beta minus p squared. Now this is minus times p, yeah? So if I need to have p squared, it means I'm squaring both sides. So that's minus of alpha beta squared. That's 1. Okay, so I don't know if this makes sense. So this is going to be alpha to power 4, beta to power 4. This is 2 alpha beta minus alpha squared plus beta squared plus 2 alpha beta. Eventually, this and this will cancel. So I'm having alpha 4 beta 4. Then minus, if I open this bracket now, minus alpha squared minus beta squared. But how does this make sense? Now I know that alpha is that. So this is 1 over beta cube times beta raised to power 4 minus 1 over beta cube squared.
So Daniel, did you forget the +1?
Oh yeah, +1. This doesn't look good yet. Just trying different things. So this is gonna be beta.
But shouldn't the alpha also have the power 4?
Oh my God, that's gonna be power 12. That's gonna be power 12. No, this doesn't make sense. So if I do that, that would be like power what? 8. This is too long. Power 8 here, power 6 here, and I want to add 1. And how does this become 0? Not yet. Okay, this is what I'm gonna do. Let's when we meet next time, I will try to see what I'm missing or which approach I haven't used. All right, then we can look at it together next time. But if anybody wants to try, please try and send me what you are able to get. I don't know why I'm sure I am just missing a trick. It's been so long I did something like that. I think it was my high school days or maybe early 2000. So I don't know why I'm missing a trick. Okay, so let's forget 15. If you're able to try it, please do. You can also try 14 is similar. So if you're able to do 15, we can do 14 as well. Okay, but you should be able to do 12. Okay, I'm going to share my screen. Should be able to do 12. Okay, 12 looks like 11. Can you see? 12 looks like 13. All right, talk to me, please.
Yep.
Okay.
Okay.
So that looks like that. So this might be easier because this is not reciprocal. You might want to try this because it's not reciprocal. It is simply alpha equals beta squared. Okay, this is just alpha equals beta squared. You can try that. But this is cube of reciprocal is probably the big deal. So I'll check. If the question is right, then maybe I've not been doing something right. I'll check. There's so many questions telling you one equation is twice the other, one equation is 2 twice the other plus 1. There are so many questions that can be given. All you have to do is establish it the way we did from the beginning, all right? So can I ask you, some of you, to please try and send me your attempt if you're able to get it. Then when we meet on Wednesday, we can share ideas together, all right? Like I said, this is way beyond your level. This is way beyond your work. We're just trying to make sure that, okay? I'm just trying to make sure that we can, go as far as we could in terms of stretching ourselves, okay? Questions, please?
Mr. Daniel, can you like go back to the board so I can screenshot like every page from like the beginning?
No, I will send you the page. It's auto-save on my computer.
Okay, okay.
Meeting, I'll send the page to WeChat. All right.
Mr. Daniel, I think you didn't send last week's lessons pages on the notes and.
Oh, really? Okay.
Yeah.
I'll send last week and this week.
Okay.
I just send the pages. I just upload the video. So if you guys
I use the video to copy down the notes.
All right. So if you want me to send the pages, I still have from the beginning of our lessons. I still have all the pages. If anybody needs any particular class page, let me know. I have everything from the beginning. All right. All right. So I'll see you guys on Wednesday. Okay. Bye, everybody.
Bye-bye.
Bye-bye. Bye-bye.
Bye.